expressed as a ratio, which is just like a fraction. Here's what it looks like. When you're thinking of slope, you're going to find the change in the y points on your graph, the change in the y. And then you're going to place that over the change in the x value of the graph. In other words, you're going to think of the rise, how much it goes up in a graph, over the run. Rise over run as a ratio is going to be change in y over change of x. A lot of fancy math speak. Let's actually put it into an example. We want to determine the slope of this graph. And to determine the slope, I need to find 2 points that I can use as a reference. Where do I see 2 points that like cross exactly at a whole number? I don't want to use like over 3/4 0. That's an ugly one. Don't write this. But like this point right here doesn't make sense because I'm kind of guessing at where it is. I'm not really sure if that's over 3/4. I want one where I'm almost certain it's a whole number. Alexis, what point do you see? Over 1, up 1? That's a pretty safe bet. So let's make a point at 1, 1. That'll be a pretty easy one to decipher. Okay, and remember when you plotted a point, you just found the x and the y. What's another point I can use, Jacob? Over 2, up 4, sure. You might have also been tempted, you could have done 0, -2. That would have worked also. So any of these will be fine. We just need 2 points to find the slope. So let's just use these 2 for now. This point, you said, Jacob, was what? Over 2. Okay. So we just said that the slope is always the rise over the run. So the rise is how much the points from the y changed. We went from 1 up to 4. From 1 up to 4. Well, that changed, or it went up. It rose 3 units. We went from 1 to 4. So I'm just looking at the y part. I'm not going over it all yet. I'm just looking at the y, and I went up 3 units. The run is how much it changed over. So from this point, it went over how many times? Just 1. So let's put the 1 on the bottom. We always express the slope as a ratio. So this is one of the only times when I actually want you to just leave it like this. Don't make it a whole number 3. That's not really a great way to look at slope. If you did write a 3, I wouldn't mark you wrong, but it's always easiest to look at slope as a ratio. This slope is 3 over 1. You just found your very first slope. 3 over 1. Let's look at another example. Ooh. Actually, go back up top. I forgot. Let's say that Jacob decided he wanted to use, you don't have to write this, but let's say Jacob wanted to use this point down here. And he wanted to use this point up here. Okay, so I don't want to use that first one that Alexis found. Let's just use the 2 like farthest ones away. Does it still make the same slope? Let's see. We're going to go up. Ooh, that's ugly. How many times? 6 times, okay? And then over, how many times? Is 6 over 2 the same slope? Yeah, it simplifies to 3 over 1. So any point will work. It may be easiest to find two that are close together, so you don't have to simplify. But 6 over 2 is the same as 3 over 1. Same. Yeah, TJ.
So if you were to write 6 over 2, would you still get it right, or would you get it marked down?
On a test, you would probably have like 4 out of 5 points. I want the simpler version. 6 over 2 is correct, but the actual slope is the simplest version of it. You could start with 6 over 2 and then go to 3 over 1. Yes, you can. Okay, next page. Sure. Okay. The slope of a linear, is this on your first page? Oh, sorry. It's different from mine. Keep it on this page. We're going to fill in some of these notes. The slope of a linear relationship is always constant, meaning it's the same everywhere on the line. This does not mean the line is flat. Constant. It means that you go up 3 over 1 for every single part. It doesn't mean that it's flat. It does not mean that it's flat. So I can start here and do a constant slope of up 3 and over 1. I can go up 3 and over 1. Up 3 over 1. It looks like a nice little stair step. It's because it's constant. It always goes up 3 and over 1. It never changes. Next one. This one looks weird. Compare example 1 with example 2. There's a few differences. Some are obvious. Others are a little bit more hidden. Turn and talk to your partner. What is one difference you see from example 1 to example 2? Go. Three, two, one. What are some differences? I'm looking for one that I'll point out, but there's a few obvious. What do you notice? I forgot your name. Wow. No! Wait, I just saw your test. Oh my gosh, I'm going insane. Wow. I almost said Claire or you can mark a blunder. Just mark one. It's rude.
It could be at least 2.
I already feel bad enough. Yeah, making it more than one blunder just might like crush me for the day. So it's 1. Avery, what is different? It slopes the other way. There's one difference. I also heard that like it goes through 0, 0. It goes through a different part. The one thing I wanted you to notice right away is this slopes the other direction. And every time it slopes in the downward direction, this is what you're going to think of. You're going to think of slope as a little man. Draw the little man. Make him pretty cool. And this man, unfortunately, has this rare disease where he can only walk left to right. He can't go left. He just walks right. He cannot turn around and go the other direction. And whenever little man is walking down, you know the slope is always negative. Little man is walking down, slope is negative. So I'm going to put a negative in front of the ratio. Take a look at example 1. If you drew little man on here, he only walks left to right. So he's got to walk up. This slope was positive. He is walking up, it's positive. Little man is walking down, it has to be negative. So once you notice it's negative, you can find your 2 points. Let's, for the sake of being kind of an easy one for this, let's just choose the 2 closest together. And I'm going to start with the slope rise over run. To go from this point to the next point, how much is our rise? Claire? It goes up 2, and then the run you added on was over 1. So this is up 2, and then it goes over 1. So your slope is 2 over 1. But he went left to right, so he is going down. He is negative. The slope has to be negative 2 over 1. Alexis? He walks to the right. Yeah, left to right. He can't turn around and go back the other way. Unfortunately, he is stuck that way forever and ever and ever. You'll now be attending Harvard or Stanford or Yale and saying, hey, I remember that. That's the little man who only walks to the right. And your professor will probably say, you're fired. No. You can't fire you, so no, you can't. Yes.
Does it mean something if the line goes left instead of right? Meaning like the line that we draw from like the center line to like over.
Like that. Like if I went down.
Yeah.
Like if I chose this point, so let's erase this. So if I chose the point 0, 0 and 1, -2, are you saying that? If you chose that, you're still going to be going down 2 and over 1. So even if you go up 2, that's still your rise. Your rise is either going up or going down, anywhere in the vertical direction. So you can go from here down to over 1, up to over 1. This is still the same slope. Up to over 1. Oh, that's ugly. Up to over 1. Yeah, so you can flip it as long as you're following that same pattern. Up to over 1 or down to over 1. You can also say that m is equal to -2. M is the slope, so this is another way to say it. I told you slope is usually a fraction, but this is not technically wrong. -2 is the same as -2 over 1. So you can see slope like this. But think of it like this. Next page. Maybe? This is the same page? Okay, next example. Determine the slope of this graph. Find 2 points for me. Give me one of the points that you notice is a whole number, Claire. 0, 1 will work. And what's another point? Oh, sure, just give me one. Anywhere along the line would probably work. Yeah, 1, 3's up here, so that gets detention. 1, 2. It's kind of hard to see on the board, but it might be easier looking at your paper. Oh, so that one's pretty good. It's going to go rise of 1 and a run of 1. When it's 1 over 1, it's probably just going to be written as the number 1, but you can think of it as 1 over 1. This rise is 1 over 1. What? Nope. No. Did I say that I would mark you down if you put the slope as 3 over 1? The simplified version. So if I had like this, yeah. So I don't care if it's whole number or fraction. I just think it's easier for you to think of rise over run as a ratio. So always kind of revert back to a fraction. If I had this and this point, and I had up 4 over, is this up 4 over 4? Yeah. 1, 2, 3, 4. Wait. Ooh, that doesn't work. Ooh. Oh. Hold up. Back up! Okay, yeah, you're right. We gotta erase this. I remember why I threw this example on here now. So when I looked at these 2 points, I was like, hey, those look pretty close, right? But then I started going down here, and thanks for asking that question, because it made me realize this actually doesn't cross at 1 over 1. It starts getting kind of weird. And you might notice that and then kind of have to pay closer attention. This is really an estimate when you're finding slope with a graph. It's not the most precise way. And so with this example 3, I'm not going to throw this on a test and trick you. You'll have ones that are very, very easy to find if you're asked to find slope with a graph. But this is an example of it kind of just being an estimate. And so I'm going to find a point that I know is going through a whole number, which I've noticed down here, that looks pretty precise. I'm going to mark that one as my first one. And then what other point should I use? I'm in between kind of like 2. 0, 1, and 1, 2 look pretty close. 1, 2 looks even like more precise. So let's put the dot there. 0, 1 looks really close. If I'm not paying attention, I'd probably mark that. Let's go up. What is the rise of this graph, Kira Murphy? How many times did I go up?
7.
Okay. And what about the run, Jillian? Yeah, so this slope is 7 over 6. You do not need to make it into a mixed number. The ratio is always what you're going to use. 7 over 6 is the slope. 1 over 1 was close, but I looked closer and it just didn't match as well. Yeah, Claire. Where at? That's why I didn't put m equals 3. Technically, it's 3 over 1.
Yeah, it equals 3. It's the same thing.
Flip to bronze while I'm doing the walk.
There is there's only gold. There's no bronze.
Here, there's gold. There's no bronze. Oh.
Okay. Moving on. So head to this page. You guys have kind of a mixed up packet. You have gold, and then you have the last notes page, and then you have bronze. We're gonna fill out this final notes page, and then you have 10 minutes for bronze. Bronze is just the one that says IP. It's independent practice 4-4. IP, independent practice, IP, independent practice. Okay, last section of notes. If it is a positive slope, it is going to be increasing. So as x increases, y also increases. Draw a slope anywhere along, as long as it is positive. Here's your little man on the line. He is walking left to right, and he is increasing. As you go this direction for x, the line is increasing for y. X increases and y increases. I'll leave the parentheses blank for now. If you have a decreasing slope, as x is increasing, y is going to decrease. And this looks like this. Draw a line anywhere, and your little slope man is walking left to right. He is going down. You know it's going in the negative direction. As x is increasing, y decreases. It goes down. And lastly, you might have a 0 slope. That just means there's not a slope at all, and this is constant. As x increases, y is going to stay the same. X is increasing. It's going to the right, but it doesn't go up or down. This is a slope of 0. Here's your little man. And he likes it when slope is 0. He doesn't have to like climb or fall down. He just likes to chill. That's a slope of 0. He is putting off 0 energy to stand on the slope of 0. Get it? Last one. This is a slope of 0. He is putting off 0 energy to stand on a slope of 0. He's just chilling on solid ground. I'm just making this up as I go, you guys. This is my like 6th year of teaching, and I have never done that before. So good, yeah. Make a quote book for me, please, and then publish it. And then give me all your money. Just kidding. Last one. This is a weird one because it's going to have a slope that looks like this. If you have a slope that is vertical and the y is increasing but x stays the same, watch what happens to our little man. He's trying to stand on here and he's trying to walk left to right, but he cannot. This is a slope that is called undefined because he cannot stand on that. There is no slope. It is called undefined. Undefined because if you have your rise be some number, your run is going to be 0. Any number over 0, you cannot divide. So this is an undefined slope. He tries to stand on there. He falls. Unfortunately, he perishes. Or maybe he just falls into a lake and swims around. Sure. Or that, yeah. You're on your next page. Independent practice looks like this. You got 10 minutes. Work your way through finding the slope. Remember that this is an estimate. So if you get one that's kind of off, go back and look. Just a second. Oh, shoot. That's okay. Go back and look at your answers, and if you're a little bit off, you probably didn't like totally get it wrong. They probably just used a slightly different point. So try to find the point that they used and use that one because it's probably the most accurate. If you need to whisper back to a partner, that is fine. Work your way through as many of these as you can. Go.